Okay, after you know that states in AI, now we'll move to the next topic, that is the logic. I'll talk about two kinds of logic. This is one of very important knowledge representation in AI. You can use logic to represent the knowledge in AI, and it's it's very powerful. So you can use the logic to represent some knowledge, and also I will, if we have more time, I will explain about the other kind of logic also. Uh, the logic that we will study in this session is the propositional logic and the first order logic. But actually, there is another kind of logic that is the fuzzy logic that we don't have enough time to talk about the fuzzy logic, but I will talk about these parts. That is the propositional logic and first order logic. The idea of the propositional logic is the one that I think, you familiar with the propositional logic also. I think, uh, for example, maybe you think you familiar with this kind of sentence like if P then Q, you can interpret it like not P or Q, something like this, right? It is logic. So I think you're familiar with this. So we start with uh, using logic to solve some problems, and you can use logic in many documents, in especially the law, that someone try to interpret the natural language into a set of uh, the knowledge and try to conclude something from the logic. So guys, uh, I think you're familiar with this one, and we can use this kind of logic to represent something in the real world. Okay, many things. I'm sorry. I'd like to rewrite it again. The one that we will study is the we call we call this problem the uh, wampus, the wampus world. And what is the wampus world? The wampus world is uh, the grid that if you were an agent, this agent must walk in this grid, and this is an agent, and try to grab the gold from some cell. But there is a wampus, that is it is the demon, the devil that can kill you. This is a wampus, and there's some gold in some cell, like this, and you have the pit that you cannot fall into the pit. So this is, for example, this is the pit. Okay. For the cell or the grid that is adjacent to the pit, there will be breezy. It is breezy, has a breeze here. So all cells or grids that is adjacent to the pit will be breezy. And for the grid that is adjacent to bumpers, it will be smelly. Okay. So in the cell of gold, it will be like glitter. So this world is please think that the world is not so complicated. Maybe you can think that okay, if one person is here and the pit is here, you may think that okay, it is also breezy and smelly, so the breeze will blow the smell away. No, 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 no. Okay, please don't think like that. If you if the pit and the wampus is in this position, you will have both. It is smelly and breezy at the same time. Okay. So you can represent the knowledge in this form possible in both propositional logic and first order logic. So guys, it's like something like this. If in some situation your agent walk into this world and you can find that it is safe, so no breeze and no smell, but once you move here, you have a breeze. It's breezy. So you don't know that this is pit or not, right? So you decided to go back to the place that you are confident, like go back to this grid and go up, because from this position you already known that it is safe, because there's no pit, there's it's not breezy, it's not smelly. So it means that the grid that is adjacent to this grid is safe, right? So you can move up, and then you may get some smell. It is smelly, so it is maybe it's wampus or not, or wampus or not. So how can you move after this point? How? This is the question that I think for human like us, we can answer these questions very easy, right? So is it easy for you? You can pause the video clip for a while and try to think about the answer, that how can you do with this situation. For the human, you can apply some knowledge from the logic field. Okay guys, please pause the video now and try to answer my questions, that how can this agent do. Okay, please pause the video. Okay, or if you can hear, or if you play the video and up to this point, it means that you already found the solution, right? So how about your solution? How about your solution? So if we name the grid like this is the grid number 1, 2, 3, 4, 1, 2, sorry, 1 2 3 4. Okay, so what does it mean? It means that it breezy at x is 2 and y is 1, right? And it is smelly at 2 1, right? So what is your solution? Is it a pit at 3 1 or not? Or the pit at 2 2, or the pit, sorry, or 1 plus at 2 2, or 1 plus at 1 3. So how can you find some conclusion from this situation? Okay, so this is called the reasoning. That we will talk about the reasoning later, after you already know the concept of propositional logic and first order logic. We can find some conclusion. The idea is quite simple. Of course, guys, what does it mean? It means that if for human, if a person or if an agent is here and it can smell the 1 plus, it means that maybe 1 plus is here or 1 plus is here, right? So this is the rules that you are using. And how about this one? This is if you know that this cell, this grid is busy, it means that this is a pit or this is a pit. So I think you can know from your experience that the answer is okay. The answer is like this. If the rules is like this. If the cell 2 2 is a pit, what happened? Then this is a symbol of if then. If cell 2 2 is pit, so it must be breezy at 2 1, and this is a symbol of and it must be breezy at 2 2, and it must be breezy at 2 3, and it must be breezy at 3 2. So if P22 is a pit, so this condition will be true, right? Or you may have some idea that if P22 is a pit, then it must be breezy at 1 2. If 2 2 is a pit, it must be breezy here, right? So this is so this is one rule, right, in your mind, but the more or complete rules is here. So you can capture some part of the rules by using your knowledge, but I will talk about this later if if we want to talk about the reasoning, I will tell you how can we do it. Okay, and from now, if the rule is like this, it means that if something like if A then B, if A is true, you'll know that B must be true, right? But in the case that you know that B is true, can you conclude that A is true? Okay, let's think about this. If it's rain, the floor, the grass will be wet. If you can find that the grass is wet, can you conclude that it's rain? Can or cannot? Sure, if you study computer, you cannot conclude. If you find that the grass is wet, you cannot conclude that it's rain, because there can be many reasons why the grass is wet. The rain is one of the reasons, but there can be more reason than that, so you cannot conclude, right? But if you know that it's rain, you can conclude that the grass is wet. Okay, so but something can be done like this. But if you know that if the grass is not wet, it's not rain. It's not rain. Okay, so this is like the knowledge that you can represent using the logic, in the form of logic. If it's rain, if it's rain, the grass will be wet. But if you can find that the grass is wet, if the grass is wet, you cannot conclude that it's rain. But if the grass is not wet, if the grass is not wet, you can conclude that it's not rain. This is logic. So what does it mean? It means that if you know that if 2 is a pit, you can conclude that P1 in the grid 1 2 will be breezy. But if you know that 1 2 is not breezy, 1 2 is not breezy, 1 2 is not breezy, it P 2 is not a pit, right? So in this situation, you can find that in 1 2 is not breezy, right? Because in 1 2 you can find that it is oily, it's smelly, but not breezy. So it's not breezy. It means that this one is not a pit. If this one is not a pit, this cell must be a pit, because one or both of these cells or these grids, one of them or 2 of them must be a pit. Because if one of them or 2 of them or both of them is a pit, this one will be breezy, right? You can find that this one is breezy, so it means that this one or this one. And now you can find that it's not a pit here, so you can conclude that this one is a pit. In the same way, you can conclude that this one is a wampus, because one of 2 cell or two of them must be wampus, because you know that this one is smelly, right? So one of them or two of them two of them must be 1 plus. And now from this cell, you know that it's breezy but not smelly. In the same logic here, if it is not smelly, it means that this one is not 1 plus. So one of them must be 1 plus. But this one is not 1 plus. So the 1 plus must be here. So you can conclude that this is the fact that you can conclude from the logic that this one will be 1 plus and this one will be a pit. Okay, so now the agent can move here, right? Okay, so guys, this is just the first example, and I will introduce you another method to find some conclusion for the propositional logic. Okay guys, see you in the next video clip.